So for today, we have a very special presentation. I am going to present, but I also am going to do what I normally do because I know you guys tend to get a little sleepy during the old slideshows. And I'm going to show you guys the in-person components as well, what I have here. So it'll give you a little bit better of an idea of what you're actually seeing. Most of you are already in the trade. You're already in the field. You know what they look like. But sometimes putting them all together in a way that's easy to understand is helpful when it comes to troubleshooting, because a lot of the time we learn to troubleshoot one part at a time and not a whole system. That can be a problem sometimes. All right, so I'm going to, Emmy, you think we're okay to go into the presentation? I think we have quite a few people here.
Yeah, definitely.
All right, so we're going to go ahead and do that, guys. I'm just going to share my screen. And here we go. Okay, residential systems components. So these are all components that you'll see in residential systems. I did not go crazy on any commercial or industrial stuff at this point, but we will get there eventually. So for now, this is what we have for boilers and furnaces. Pretty self-explanatory. Excuse my horrible boiler graphic. There's just not a whole lot about like with graphics that are broken down easily when it comes to boilers. And I'm not sure why, because they have pretty much the same components as a furnace, except for the heat exchangers are different. They still do the same thing. We have expansion and we have water instead of air, obviously, but it's not a whole bunch different. So you've got your blower, obviously on this one you don't. You've got secondary heat exchanger and primary heat exchanger. That's important when you are checking things over and doing a maintenance, or if you're trying to troubleshoot something, because a lot of the time the secondary heat exchanger just gets missed and it gets nasty or it gets cracked and we don't check it because we don't know it's there. So that's super important for me to show you guys that exists. Then we have our exhaust, another super important thing on both boilers and furnaces. If your exhaust, if your flues are not clear, you will have all kinds of issues that will tell you that they're airflow. They'll tell you that your heat exchanger is cracked. They'll tell you it's dirty. They'll tell you all kinds of things when really all it is a, mama bird making her nest in this exhaust vent. Always check your exhaust vents on maintenance. Make sure that you do. And that, again, goes for boilers and furnaces. You have Venturis as your burner here on boilers, whereas you have burners also on a furnace, right? You have the same thing. It just looks different. Does the same job. With a furnace, you have combustion air intake as well. Both have drains. You will have a condensate drain on a boiler, just like you will on a 90% or higher furnace. That's another super important one. In the winter, when we put 90% plus furnaces in attics, they tend to freeze. The condensate tends to freeze. So if we are doing that, we need to make sure that we're running a condensate that can handle that kind of low temperature. We need to make sure that we're putting heat tape around it or whatever we can do to make sure that that drain line isn't going to freeze, because when the water freezes all the way up the drain line, it freezes into the unit, right? That's not a lot of fun when that happens, because you're chasing a bunch of stuff that really is just water. And then I actually had one this year in Boston where we couldn't get it freed up. So we had to cut it out and run a whole new condensate. So it's not a lot of fun for the customer either. You'll always have a trap on that condensate line. That is to catch any debris before it, gets clogged in the pipe or goes back and feeds back into the unit. They also should always have a vent as well. You don't want a closed trap. That's pretty much it on the furnace. And then we have a gas valve on both. Super important. Gas valves go bad all the time. And typically when they go bad intermittently. They do not fail outright. So you'll have one that is firing maybe 1 out of 3 times or 1 out of 5 times, or, only fires, twice out of 10 times. It doesn't matter how it fails. When it fails, it will fail intermittently at first, and then eventually it won't become unstuck. So I will show you guys that in a later slide, but that's typically how gas valves fail. So then all of them have, obviously, pressure gauges. They have pressure switches on both. A lot of them are very, very similar. So we're going to move on into residential air conditioners. I was going to do just evaporators for this slide, but it's pretty self-explanatory. The outdoor unit is always the same, pretty much, has the same components in it anyway, might not look exactly the same, but the indoor units can differ. We don't have a ton of indoor units that are typical to residential, but if you go across refrigeration and industrial, you'll end up with a whole ton of different evaporators, which eventually we'll get into as well when we do our commercial courses. But for right now, we're focusing on residential. So you guys have seen all of these. Even those of you who haven't been in the field, this one is a little bit more elusive because it's within the ductwork. But then you have your mini split over here. So a coil is going to be far different than a mini split. It does the same thing. They're both evaporator units. However, they operate differently. So this is just a coil. This is nothing but a coil, right? And it's got all these different, distributors and capillary tubes and all that. What it is the same pipe run to different spots pretty much. So it all connects together for one refrigerant cycle. So you won't see this one out on its own, but you will see it in every single conventional split application, whether it is a coil or not, it's still going to be a coil. So this coil will sit on top of your furnace, and it will, if you have a dual fuel system, you'll have this coil on top of your furnace, whether it's a heat pump or not. This will provide AC, the furnace provides heat, or they can go back and forth to provide heat via the heat pump and the furnace. Super self-explanatory, you guys. It's literally just a coil. And then on the other side over here, this mini split. Mini splits have a blower. The blower is directly correlated to the coil. So when the coil hits the typical standard temperature that it needs to hit in order to do its job, basically, then the blower will come on, blow across those coils, and that's what transfers the heat or pulls the heat out, depending on what mode it is in. These are the ones, I actually have one behind me that I'll show you guys, but these are the ones that we see a lot now, but you wouldn't have seen a lot 5 years ago or 10 years ago. So those of you who are advanced techs that are brushing up on new technology, you're seeing a lot of mini splits right now. They're not for everyone and they're not for every application, but people sometimes think that they are. So that's where we run into a problem. I will talk about that in a further troubleshooting course, but for now, this is the outdoor unit. This is, again, we went over this in the refrigeration theory course. We have our compressor, we have our outdoor fan, and our condenser coil. There is a lot more electrically to both of these parts, but for components that we're going over today, this is what we're going over. And I will get to the electrical components in a separate slide. Self-explanatory again, guys. This is an air handler. So this is just to show you guys that setup I was talking about where you'll have a furnace and then you'll have an A coil on top. It all is within the ductwork. It will look like one system. You've probably seen a million of these in your life. You just didn't realize that they were two separate systems. They're not. They work as one system, but it is technically two separate components. And then again, here's a different style condenser, which is what I wanted to show you. This is what you'll see a lot more often than those thin ones. The thin ones are typically for mini splits and for smaller. You'll see them in like 1 to 1.5 ton coils will come with those ones. But this is typically what we see. So we've got our condensing unit, which again, fan, condenser coil, compressor. You'll have, filter dryers or sight glasses, not on AC, but you'll have other little components in there, but they don't matter. They're not enough to wreck the system. Other than, I'm glad that there is a filter dryer here because when we're talking about restrictions, it's not always the TXV, regardless of what every HVAC tech in the world tells you. It is not, in fact, always the TXV. And then I just put a little note on here. For my really new techs or techs that aren't techs yet, all evaporators are connected to a condenser. So you will never, ever see just this part without this part being outside. They have to work together. They have a cycle. If you haven't watched the refrigeration cycle training yet, go back and watch that. And these work together. The lines basically bring the refrigerant inside, goes through this coil, then back outside to reject heat. That's just in a super, super duper small nutshell. All right, question time. What do you think is the most common reason an HVAC system fails? If anybody has a guess, go ahead. Just try to if somebody starts talking, just wait on your turn. Somebody, anybody. I know you got it, Jason.
A restriction?
That is a very good one. So that can mean two things. Are we talking a restriction in the refrigerant line, or are we talking a restriction in the airflow?
The airflow.
Very good. Dirtiness. So lack of maintenance is the number one statistic reason that an HVAC system fails. And that goes for every single HVAC system. That's not particular to heat or to AC or to residential or commercial. That is every HVAC system. That's because these systems are not built in a perfect world. They would never collect any dust. They would never, have anything bad happen to them. However, it's not a perfect world. So stuff happens all the time. You'll see them outside with, banana boxes or trash piled up on top of them. You'll see a blanket over the coil of dog hair and fur. And even like dogs going to the bathroom. Dog urine is another, it's high up there on reasons that HVAC systems fail, because they're outside, the outdoor units are outside, and dogs don't know any better, and they end up crumbling the coils. It actually poisons the coil and turns it to acid. So yeah, that's a thing. But yeah, lack of maintenance. So not having an HVAC tech come out to your place and take care of your unit at least once a year. For commercial customers, we always recommend quarterly, so it would be 3 to 4 times a year. But even our HVAC customers, we suggest having both your heating and your air conditioning units cleaned twice a year. When you don't do that, you end up with things like Jason said, airflow issues. So it's not able to reject the heat outside. And then, it's not cooling and you're sticky and there's no dehumidification going on and your walls are sweating and it's a whole thing. So yeah, that is the number one reason. Lack of maintenance, dirtiness, particularly. So this looks complicated. To those of you who don't know better, this looks complicated. It's not, and I will show you why in person. But basically, I just wanted to go over those start run components of a condenser, like I was telling you guys. It's not that I want to skip over these. It's just that when they fail, it's very obvious. So we're trying to get into like a little bit of the more devious problems here. But basically, L1 and L2, so this one does have L1, L2, perfect, is going to be your power input, your 240. So this is your high side voltage is what we call it. So this is going into it says relay here. This is a contactor. A contactor is technically a relay. That's why it says it, just not to confuse anybody. So L1 and L2 go into the L1, L2 side. Self-explanatory on the contactor, okay? And then the other side, so these can be either horizontal or vertical. They can have a whole bunch of different ports, or they can have only a couple like this one. But for theory's sake, we have T1 and T2 out. So basically, it's like any flow system. So we talk about boilers and furnaces being water and air is the flow, but they're the same system. They do the same thing. So in this situation, the flow is free electrons. It's electricity. So the same way that water flows or molecules flow or air, that's the same way that free electrons flow. We have to keep them contained. In this case, it's not pipes, it's a wire, but it's doing the exact same thing. So where we have electricity in, we also have electricity out. So in this situation, T1 goes, so these are called tines. Tines are the little pricks that come off the end of a capacitor. And I'll show you guys all of this in person so you can see what they look like. But so you're going to put your common on one of the tines, and then you're going to have Herm tines on that too. It doesn't matter what your capacitor is, what size it is, it will have Herm and common tines. So you're going to go from here all the way down to the fan. So what is powering the fan motor is the capacitor. Yes, the capacitor is powered by the contactor, but the contactor is not directly powering the fan motor. We have this capacitor in between, which basically holds energy, and it will feed it back to the fan motor to start it and run it. So we call these start run components because of that. They start or they run something in the system. The capacitor also goes down here to our CSR ports on our compressor. You'll hear a lot, can she run or C start run. And those are ways that we remember that these are CSR ports on the compressor. So your capacitor goes, so you're going from your contactor to your capacitor. From your capacitor, you're going to your compressor and you're going to your fan motor. And then also you've got grounds, right? So we see ground here. This is not showing it correctly, but each one of these is grounded. Each one of these components is grounded, except for obviously your capacitor is not grounded. That would not be good. So the reason why you can't just pull a capacitor out is because it stores electricity. So if you just grab that and pull it out, it's going to zap you. You're going to get a little shocky shock. And it's actually not that small. It's actually quite painful. I've done it. So yeah, that's basically it. So L1 and L2 line side of contactor, T1 and T2 out of contactor to capacitor and compressor, Herm for capacitor to fan motor and compressor, and then common from capacitor to fan motor and compressor. So we always have a common as well. And then we also always have a ground, or we hope we always have a ground in a perfect world. Moving on, this we didn't talk about. So we were talking about straight cool. We've been talking about air conditioning, right? What makes an air conditioner no longer an air conditioner and makes it a heat pump is this tiny little part. It's actually about the size of your fist if you're a man, a little bigger if you're a woman, but this is not a big component, but it makes a whole big difference. This is the reversing valve. And I wanted to give you guys a close-up of this because a lot of people don't know what it looks like. Like we know it's there in theory, but if you haven't had to change one, you just have no reason to really look at it. So this is important because if you do come across one that needs to be changed, you need to know what it looks like so that you can identify it in the anatomy of the system. So it looks like a lot of things. It really does. These pipes, ooh, where'd my cursor go? These pipes down here are going to the system. This pipe here is the D pipe. This is going out of the reversing valve. Inside, you have, this is the valve body. We call this the valve body. So this is where the mechanical movement works to make it a valve. And that's all valve body means. It means the thing that encases the thing that moves, basically. So inside we have a slider and we have a support. We have a piston that goes in and out. We have a valve chamber, which is basically what I just told you, the valve body. And then we have a pilot slide valve. This is what slides the inner workings of the body, left or right. And what this does is it changes the flow of refrigerant. So if you are in cool and you've got refrigerant coming here, coming through here, and then back out, and here, and then back out, and here, and then back out. If you've got that happening, then you click heat, and you need it to go into heating mode. This whole inner valve body right here, so this pilot slide tells it to slide that way. And now you've got the refrigerant coming through here and going this way, here and going this way. It actually happens in these pipes, but yeah, just to show you on the valve itself. So that's going to go in one pipe and out the other. So say it's going like this for cooling, and then you hit that reversing valve and it's going to go like this the other way for heating. And it does exactly what it's already doing in the refrigeration cycle as far as that goes. But instead of cold, we're going hot. Instead of hot, we're going cold. So basically the way that they fail, this one's tough because these are misdiagnosed all the time. And my people in here who are already techs, I just want to tell you that if you've done that, you're not the only one. And it's a very common thing that we misdiagnose. I have done it before. So basically how they fail is they stick, right? So this part of the valve body no longer moves, whether it's this way or that way, it sticks. That's what happens. So when it sticks, it can make a very loud, very annoying sound when you go to throw it from heat to cool or cool to heat. It doesn't always do that though. So this is not always a good diagnosis is just by sound. But if it is failing and you can hear it, it will sound like a loud chattering or a hissing. Some people say it sounds like a hissing sound. But it will always not cool or heat right. You will get a call for this because they will notice that it's not cooling or heating right. It won't swap from cooling or from heating. So if it's stuck in heating, it won't swap to cool. And if it's stuck in cooling, it won't swap to heating. It never will swap, but is not broken, but is broken. It's one of those things where if it's not working, it's not sliding, it's stuck. You will notice that there will be a poor defrost cycle. It either won't go into defrost or it won't stay in defrost. And then also it causes high energy consumption. A lot of people don't understand this. So if it is stuck, it will just constantly draw power because it's trying to do what it's supposed to do, but it can't. So it just keeps trying all the time. So we will have a high power bill when it comes to that as well. All right, gas valve and regulator close-up. This is not something I want to spend a whole lot of time on, but like we talked about earlier, gas valves fail intermittently. And they fail because they either get gummed up or because the gas is not right. You didn't convert it to the proper gas, or it's just a crappy gas valve to begin with. And we see a lot of those in the field. We see 3-year-old gas valves that are failed. So
Wow.
basically what's going to happen is gas is only going to come out sometimes, or it's not going to come out at all. And then, so that's what it does. So you have your inlet from this regulator. You have an inlet into your gas valve. Your gas valve steps it down like a transformer, except for gas, not for electricity. Steps down that gas to 11 inches water column or whatever it happens to be that your gas valve is on and it calls for. This regulator comes before the gas valve. This is on your actual gas line. And this regulator steps it from full pressure to 2 psi, and then from 2 psi to 11 inches water column further down the line here in the gas valve. You can have multiple regulators. A lot of systems do, because you don't want full gas pressure coming at this. That would absolutely blow this gas valve apart, and it would cause combustion probably at that friction. But yeah, they're self-explanatory. It's just like how we showed you with the reversing valve. They are mechanical valves. And what they do is either go up and down to stop it or flow the gas, or they close altogether, or they open altogether. Pretty self-explanatory. I will be doing more on the gas side, but there wasn't a lot of it about it in your course, so I don't want to spend too much time on that. All right, question time. I promise we're almost done with this, you guys. It's about to get fun. What are the 5 major components of an air conditioner? Who can tell me?
Compressor.
Compressor's one of them. What else?
Evaporator.
Evaporator's another one. What else you got?
TXV.
Metering device. That's right. And what's the, you guys might not get the 5th one if you weren't here for my first class, but what's the last one on that list?
I'm gonna take a
A
guess.
liquid receiver.
A receiver,
Liquid receiver?
is only in some air conditioners, though.
Okay.
Liquid receiver is only in certain air conditioners, so we don't count that as a major component. So we have the metering device,
What about a
the
reversing valve?
evaporator coil, the
Yeah.
compressor, and what coil's missing?
The condenser coil.
Condenser.
Yeah, the condenser coil, exactly. So we joke that the 5th major component is the thermostat, because you cannot make the refrigeration cycle refrigerate without a thermostat. So whoever came
Right.
up with the 4 major components really wasn't thinking.
Yeah.
All right, tools needed to troubleshoot AC components. This is obviously a very small list. This is the tools that I recommend that you absolutely have no matter what on every service call. So basically I just showed 3 separate types of gauges. It's just a gauge manifold or probes. So I don't care if you have, I don't care if you have digital gauges or if you have analog gauges or if you use pressure probes. Obviously, I'm a big sucker for these pressure probes right here because they are better for the system and they're better for diagnosis. But I really don't care which ones you use. They are all exactly what you need. So gauge manifold or probes. Electrical multimeter. Right here, we have a Fluke one, just because I put a Fluke one on there. I do use a Fluke 87, and I use a field piece as well. But it doesn't matter, again, as long as it has an amp clamp. There are a lot of meters out there that do not do amps, so make sure that you have this clamp on the end of your meter before you buy it. And then a 2-port manometer. There are 1-port manometers. The reason I say 2-port is because if you're checking gas valve pressures, you need to have a 2-port manometer. And manometers can also they can check gas valve pressures, but they can also check airflow pressures. So you definitely want one of those. And then the last thing is an electronic leak detector or Big Blue. I use both. So I used specifically Big Blue brand because we're going to have a show with Viper next week, and that's who makes it. But they are also my favorite bubbles. They feel a lot less like dish soap, and they bubble more when you have a leak. So there are some bubble leak detectors that they just don't bubble a lot. They'll tend to foam, or it's kind of like, is that a leak? Is it not a leak? But Big Blue is the exception. Big Blue, you will always see like bubbles, and you'll be able to differentiate. So yeah, you can get all of these tools at True Tech Tools. We do have a discount code, which is HVA Chicks in capital letters, if anybody wants to use it. But you can buy them at any supply house as well. It won't be as cheap. I always advocate for TrueTech tools because it is much cheaper and because the people who own it do a lot for our little education industry here in HVAC.
What is that?
All right.
What
And
is
these are
that?
just some common failures.
What is that again? Can you put it in the link
It was
on the chat?
Yes, I will. I will put it in. Yep. It's truetechtools.com. And our discount code is HVA Chicks, all caps. And I will put it in the chat as soon as we're out of the presentation. Actually, Jason, do you want to do that for me? Can you put TrueTech Tools website and HVA Chicks in the chat?
You got it. TrueTech Tools.
Thank you. Yep.
I just did it.
TRU.
Yeah.
Oh, okay, thank you. It's TRUTECH, guys. So it's not TRUE, it's
Got it.
TRU. All right,
Okay.
perfect. So then we have common failures to watch for. So I grabbed the worst of the worst, obviously. You will not always see them this bad, but this is what I want you to look for. I'm always pounding on you guys about non-invasive system check. And this is one really good way to do a non-invasive system check is to look for visual signs, right? We talked about listening for the reversing valve. That's another great one. Use your senses. Your senses are the best tools you could possibly use on any job, especially a diagnosis job or troubleshooting job. So if you come up to the unit and, customer states that they smell something funky when the unit kicks on and then it kicks right back out, you're going to know to go and look at your contactor because contactors like to char. So when they char, the contacts, these are contacts, guys, up here and down here. So what happens is when this pulls in, these contacts close and they touch the other side. There's a coil back here, which I'll show you guys on the actual contactor. There's a coil back in the back of it, and these close and they stay closed to run the system. If they can't stay closed because there's char and nastiness and debris and dirt and whatever, rust, then they will let go. And when they let go, the whole system shuts off because every single component in that outdoor unit is running off of this contactor. So look for char marks, but also behind these contacts, they make little contact cleaner brushes. I usually just use a wire brush and stick it back behind there. But yeah, so look behind these contacts as well, because you'll see where these like slam closed. So these basically slide back and stay closed. So behind there, you'll see like, oh, there's a whole bunch of dirt or there's a bunch of rust, and that's why the contactor won't stay closed. I always just replace it because it's a cheap enough part, but you can clean them as well if you're in a pinch. So charred contacts, that's one thing to really look for. And I put fried start run components because that could also go for a capacitor, and I will show you guys what that would look like in a minute. But again, any charring, melting, that kind of stuff. And then the reason I say always make sure you have an amp clamp on your meter is because we always want to check our fan motors. I cannot tell you when I was starting out how many times I went on maintenances and I didn't know that I was supposed to be amping out fans. And so I didn't. And then, 2 weeks after I just did that maintenance, they were calling my boss saying, hey, my fan motor just went when you guys were just here checking all of that. Sure enough, little Jennifer didn't know she was supposed to be amping out fans. So always, it doesn't matter what you're there for. Take your little amp clamps, stick it around the wires to the fan. It's not a lot of wires. It takes about 5 seconds. Do it and make sure that you're not, overamping and burning out fans right after you leave, because that is not a lot of fun. But if you do check a fan and it is overamping, replace it. And that could be your problem depending on what the call was for as well. Burnt, melted, rubbed, or chewed wires. So again, this can happen because the contactor or capacitor fried. This can happen for lots of reasons. However, the most common reason that I see is rubbed or chewed wires. A lot of the time I will see that the maintenance tech before me or a repair tech before me did not take his time to do his due diligence and zip tie up the wires. So then when he put the panels back on the unit, one wire was stuck in it and then he screwed it in, and then lo and behold, wire is broken, cut in half, or, just shredded. That happens a lot. Also, mice love to live in outdoor units. Indoor units too, but I see them far more often. In outdoor units, I actually just had one where I didn't even have enough length of wire. I had to splice. I hate splicing more than anything. we did it safely, but I don't recommend it. So yeah, always check for mice. Open up, even if you're not there, if you're just there for a coil cleaning, open up the electrical component after, the electrical compartment after, I mean, because 9 times out of 10, there's either a mud wasp nest in there or there is a mouse nest in there. And that is probably the number 2 reason that ACs fail. And then, okay, we've got refrigerant restrictions. So this we didn't talk about. If it is the TXV, so to speak, or if you have a gummed up filter dryer, if you have sometimes I've actually seen, I had a unit come where halfway down the outdoor coil, there was a restriction and it was factory. It happened at the factory. Somebody just didn't, check the coil over well enough and it ended up making it to production and then making it to be sent out. There can be restrictions in lots of places in the system. Most of the time that will be at the metering device or at the filter dryer. So if you have one of those, you're going to probably misdiagnose 10 of these as if they are low on refrigerant. And that's okay. We all do it. But there are ways to check with your gauges, which I will teach you in a further class, whether or not it's restricted or low. So what happens a lot of the time is it's restricted, it has a bad TXV, and it is behaving as if it's low on refrigerant because all of that refrigerant is trapped in one place. So when that happens, people tend to add refrigerant. And then when you add refrigerant, it just ends up worse. So, yeah. Okay. Oop, I missed the rest of that. Sorry, guys. But the last one was just clogged drains and dirty coils. So we talked about dirty coils. Clogged drains are another huge one. We did talk about when they freeze, but also AC drains, especially in Florida and in humid climates, Louisiana, Tennessee, Alabama, you'll find drains that have what we call drain snot in them. And it very equivocally looks like a giant snot that comes out of your drain, but it does plug the entire drain line. So you won't have very much flow past that. So if you're on a maintenance and you're not blowing your drains out with nitrogen or with like hot shot CO2, if you're not doing that, you need to be doing that, especially in the summertime. So full stop. Let's see some real stuff. I'm going to go ahead and turn this off. We've had enough of the, teacher stuff. Pause share. Okay. Can you guys see me again?
Yes, I can.
Okay, cool. Perfect. So I am going to go back here and do I have any questions so far? Nope. Everybody's good so far? All right. So let me show you the real stuff. This is where we have the fun part. Mr. Baby Hand's back and we're ready to roll. So we're going to start out with this one. So this is a contactor. Hold on, guys. I can't see my screen to make sure that you can see it. Emmy, do you know how I get to my screen? Just click my name.
Yes. I can also pin you, I think. Let's see if this works. Can you see it now?
Yeah, if you could. No. I can't find myself at all, in fact. Okay, here we go. I found me. Okay, so this is a contactor. So as you can see, like I showed you guys before, you have your contactor pins. This is where your wires go. Well, sometimes. If your wires have a bite head on them, we call them bite heads, then that's where they go. If they are just a loose wire and you're not putting a head on it, they go behind these nuts. This pulls out. As you can see behind there, see there's a little gap behind the nut and the backing plate. So that will pull out. You stick your wire up in there and then you tighten it back up. They're super self-explanatory. The best way to wire a contactor, and I don't care how awesome of an HVAC tech you are, the best way to wire a contactor is wire for wire. You pull it off the old one, you put it on the new one, and then you move on. What happens a lot is that people want to unwire the old contactor and then they want to wire the new one. When they do that, they forget where stuff goes and they end up cooking stuff. So wire for wire, I don't care if you've been in the field for 50 years, wire for wire on a contactor.
I have a question. I have a question with the contactor.
Yeah, sure.
Okay. I'm a maintenance tech, and a couple times on my stores, we're doing RTU units, And when we go to
Yeah.
get a replacement contactor, right? It's the same
Mhm.
number, the same part number, 3-pole, the whole works. The difference is the cap where you put the wire in is always smaller.
Yep.
So I drill
Yes.
it out. Do you have to do that?
That's exactly what I do. That's exactly what I do. So actually, well, this one's a little bit more exposed, but these are both covered contactors. I'm obviously used to seeing uncovered contactors because nobody cares anymore. But yeah, so what happens is you'll end up with the cover doesn't cover the wires. And if you try to stuff them in there, it will actually cut your wires. So I literally drill them out and then I stuff all my wires through there and then I just zip tie them up really pretty. And really, that is the only thing you can do. You could literally aftermarket order a new cover probably, but why would you do that? It doesn't make sense, right? But yeah, that's a problem for everyone, not just for you, for sure. All right, so the difference between these, actually, I'll show you guys that. These are both contactors, right? They look pretty similar. The difference between these is that this one has the side staging pins. Some of them do not have this ordeal, and they look like this, but I wanted to show you guys both in case you're used to seeing these ones and not these. Go ahead.
I've never came across one with the side staging pins. What do you put on the side staging pins?
So that one actually came off of that one came off of a giant 10-ton condenser that was for a lobster tank chiller. That one has a separate, it has dual capacitors basically. So you've got to go from the contactor to the normal capacitor, and then you've got to go to the dual capacitor as well. So it just has some extra pins to do that with. But there's lots of different, like more complicated wiring setups that it's not for the capacitor. So speaking of which, actually, I can show you. This is cool. So I absolutely love Global, the source, you guys. The Turbo 200 capacitor. You can wire it 10 different ways. It can be wired as 5 microfarads, 10, 20, or 25. So
how expensive is that baby?
You guys haven't seen a Turbo 200.
How expensive is that baby? How expensive is that baby?
They're actually not. They're not. I actually use them for my universals now on my trucks because you never know what capacitor they're going to need. This one does like literally 10 different things, and you just wire it according to the color. Like, let me see if I can.
Interesting.
You guys can see that.
I like that.
Yeah, these are awesome.
That's very cool.
So again, on the top, you have all color coordinated. So you either use the orange for 5 microfarad, 2.5 is going to be green, 10 is going to be red, so on and so forth. So you use it just like the ones that I showed you in the last slide, but you're only using a piece of it. So basically what you do,
that's an in case of emergency. That's good. A one fits all, huh?
Exactly. Exactly. So if I'm wiring my 10 microfarad, one wire is going to go here. Then my common, say, will go here. And then I've got CSR. Like that. It doesn't actually look that ridiculous. You put a zip tie on there and it looks super nice, but these come with it just because if you need wire extenders, they want to give them to you apparently. So that is this is not a standard capacitor. This is a Turbo 200. What was that?
All right. So capacitors have always confused me. Oh yeah, that's very confusing. So, I'm very new, but yet I have done some, I've seen those a lot right there. But the Herm,
these are what
the common, yeah. So the Herm and the common, so there's usually 3 types of prongs that you see. And that's what's kind of confusing to me because I just don't know. Can you go a little bit more on that?
It is, yeah, absolutely. So it seems confusing because you're thinking too much into it. You only have Herm and common. So if there are extras, they're Herm.
No matter
if I have this wire, right? And I'm like, oh no, which one do I put it on? And my common is already hooked up. The answer is, it doesn't matter. You can put it on any one you want on that same side. So that's why some of them have more pins, some of them have less pins, some of them look like this, some look like this. They're all doing the same thing. So on this, what you would do is you would never use all of these, obviously. You would only use, say, orange. Orange has your Herm and your commons. And then if you're trying to do 25 microfarad, you would use blue instead. So you're never using them at the same time. But on one like this, a regular standard capacitor, it's just one side is common, one side is Herm. So no matter how many you have, they're all Herm.
So the fan, so you got 3 wires, you know, you got your common, your fan and your compressor wires.
Yep.
So the common just goes on common and the fan and the compressor go on the Herm, and that's it.
Yep. And it doesn't matter which ones.
Right.
Which Herm. As long as they're not uncommon, then you're good to go.
Okay.
Make sense?
Thank you.
Yeah.
Yeah.
And if they have any extra stuff, it's not for you. It's made for a different system that you're not working on. So just ignore it anyway. And most of them don't. Like the only thing you'll see, like I showed you, is if you have like multiple Herman commons. And that's just because you can use one or the other. You're never using both. And then this, well, that leads into this. Let me open this one to show you guys. This is also by Global The Source. It just happens to be the one that I have. I don't use the other ones anymore because I had one blow up on me from United Refrigeration, which really scared the crap out of me. Luckily, I was holding it with a gloved hand, actually a sheet metal gloved hand, because I would have been shocked to smithereens. This is
Your quick start.
a hard start kit. Yeah, hard start. That's all it is. Universal hard start kit. This is for up to 5 tons. There are a bunch of different ones, but that's a hard start kit. So basically what this is all your start run components in one machine. So you take this, you hook it up. So actually on the back of them, like this is so easy, you guys. On the back of them, it shows you how to hook them up and all different ways that it needs to be hooked up. So we'll say if we're going 1 to 2 tons, then you have your green wire is actually jumped to Herm. We don't have a green wire on there right now, but your green wire is jumped to Herm. So 2 Herms together. And then you have a common, and then you have 1 wire to Herm. And that's it. You hook this up, 1 to common, 1 to Herm. Nothing else. And then
So
your whole system will
Jennifer,
run.
I have a question. So is it as
Yeah.
you're boosting the run capacitor by adding a start capacitor?
So in theory, yes, but typically we replace them with this, and then we have to go back
and replace it with a starter.
We have to go back and replace it to OEM after that because these will burn out super fast. You don't ever want to leave one of these. And you'll see if you do refrigeration, you'll see really small ones. It's literally doing the same thing as this. Like I said, 1 Herm, which is, you know, your capacitance. You have 1 Herm and then you have 1 common, and that's it. These are great in a pinch. If you don't have any on your truck, get them on your truck, because if you are in a situation where you can't get the right capacitor, or you can't get the right contactor, or you can't get, you know, any part that is for start run, you can put this in there for temporary circumstances and then go back and change it.
Okay.
So that's super important. And this also comes with these, I don't know how good you guys can see it, but these are color-coded wires so that you can hook your Herms together for ones that need to be jumped. So most companies make it super easy, super simple. Again, the directions aren't even in the package. They're right on the back of the hard start. So you can't mess it up. If you're following, if you know the tonnage of your unit anyway, then you can't mess it up. All right. Who can tell me what this is?
That is a pressure switch.
That is a pressure switch. Yes. This is a really big pressure switch because, again, it came off like a 15-ton or something. Anyway, so this is made to, what's its job, Jason?
Its job is to protect the system from pressure too high or too low.
Yep.
The compressor,
exactly.
It's to protect the compressor.
Protect the compressor at all costs. This one did. It fried, and that is why it's no longer in the system it was in. So this one did its job, and it sacrificed itself, but that's okay with me as long as I didn't sacrifice a compressor that was like 25 years old. So that's why that was here.
That's the monster.
And
That
laugh.
is huge. That's huge.
So, so yeah, that I don't even know if I'm gonna. I'll show you guys the systems I've been working on at this place. It's called Sea Salt Lobster. It's one of the most famous lobster places in Maine. Those of you who don't know, I'm a Maine girl, so I work on a lot of seafood places, a ton of them. This place is like half restaurant, half seafood market, and they get the best lobsters in the country. So everybody is just swamped there. And when I work there, I'm like preferring to be in a room that's -20 because if not, I'm in a room that's 105 with all these people.
Yeah.
So this is a fan motor. It is not special. They scare people. They scare people a lot. And a lot of people do what I do or what I used to do and don't amp them out because they're like, I'm not opening the front of this case, getting in there, and then amping that out. When you don't, you end up opening that case, getting in there and replacing it because these go bad all the time. They're super easy to replace. As you can see, a few screws, and that's it. So your fan blades will go on this. Obviously, this is not the whole fan. This is just the motor. Most of the time, more often than not, it's the motor that goes and not the fan blades. A lot of people are taught a lot about fan blades breaking or wobbling or all these things that can happen. I've probably seen that twice in my whole career, and they were both evaporators that were well below 20 degrees and they froze, and that's why they broke. But the motors, they go bad all the time. And I mean, I probably change one of these a week. They're bad. Make sure you're amping them out. It will say right on it what your amperage should be.
Is that
So
from the
this
fan
one
blades like
is-
hitting the ice?
So basically so like what happened to this actual place is that they were keeping the walk-in door open all the time. So it was building humidity in there. And then they finally shut it like when they were gone for the weekend. And then the next day they'd come back in. It was a block of ice. So you're talking like the fan blades are in a block of ice.
Whoa.
So they're still trying to go because this bad boy's still amping up. This thing's still trying to turn.
Crazy.
But those fan blades are just, yeah, like smacking into ice, but not even barely moving, like trying to plow through the ice, basically. So they crack in half, and those are steel. So that's pretty crazy to see that happen. I do have a bunch of them at the shop that I'll show you guys one day. I want to do an episode of this where it's like things that can happen and then show you guys the broken pieces, because if it's something complicated, if you're working on something and it's taking a really long time to figure it out, it's usually something really bad. And sometimes really bad things do happen. More often, though, things like this happen. Stupid little things like this, where you're chasing down refrigerant and you're gauging up to the system and you're like, what is going on here? All my electrical's good, but really it's just this stupid thing turning slowly. And that's what's making you have, an uncomfortable customer that's complaining. All right, so those are the components that I wanted to show today. If you haven't watched the refrigeration cycle episode yet, go do that, because we went over all the other components in that one. We did the compressor. I just demoed out a really big coil. So I took some pictures of it and framed them because I want to show you guys that because it's a lot of fun.
I have a question.
That's probably going to be on the next one. Yes, absolutely. That's what I'm opening it up for right now. Questions?
Now, on that, did you record that refrigeration, or are you going to have another class?
So we record all of these. Every single one that we do, we record. Emmy, do you want to tell them where they can be found?
Yeah, all the recordings can be found on the app. So there's a community tab on the app. And once you go there, you'll see a link towards the top of the page. Will say like, click here to view recordings of past webinars or something like that. And they'll all be there one after the other.
Absolutely. So they're all
Okay,
accessible
thank
to
you.
you guys. Like I said, I don't teach every week. I usually do every other week, but the stuff that Emmy has come up with for you guys is like, I mean, it's next tier. It's awesome stuff. I'm just going to go into the SkillCAD app and try to show you guys real quick so that you can see what it looks like. So when you are in the app, this is what it looks like. Obviously, you're on whatever training plan you're doing. But if you click this little tab, where's my finger? Over here, community, which is how a lot of you got here today, but it'll be at the top. View recordings of past webinars, it says right there under the big black letters. So it's super easy to find. If you want to watch any of the past ones or you have to miss one, I fully recommend going there and doing that. And then does anybody else have any more questions?
I just want to say happy anniversary.
Thank you. It was my anniversary the other day, you guys. 16 years with my HVAC husband. So if you ever wonder how I got here, that's how.
Congrats.
You're welcome.
All right. Any other questions?
Thank you.
I got some
Sorry, what was that?
questions
I didn't hear
about.
you, Michael.
I was saying congrats.
Oh, thank you. Okay, go ahead with your question.
So with the certificates for SkillCat, I see that, because I just got this membership and I'm trying to, so all the certificates, they're credible.
Absolutely. So
Yeah.
I actually am I'm one of SkillCat's first students ever. So I graduated from SkillCat. I did the trade school diploma back when that was really big. It was before they separated between residential and commercial. It was brand new. But I got my EPA through SkillCat. I ended up going to MIT from there and becoming a mechanical engineer. And I've owned my own business and been a service tech ever since. So yes, 100% legitimate. And where it gives
cool.
you certifications, you guys might wonder what to do with those. What I did because when you go through every course, you get a certificate, right? And it's kind of like, what do I do with all of these? What I did was I bought one of those binders that's like sleeved pages, and I made a portfolio. So every time I would go in for a job interview, I would slap that portfolio down on the table. Like, here's all my credentials. Here's everything I've learned. They would after the first 3, they're like, oh man, we're still going. You know what I mean? So it definitely looks really good on your part when you do that. I fully recommend printing them out. And as far as your EPA card goes, make sure that you do the ordering of the card. But even just your, like the one that they give you with the letters when you first graduate, even that right there, you can bring that right to the supply house and use those letters. So 100% legitimate.
Okay.
And I believe we're the only place online other than ESCO that you can get your EPA. And we are definitely the only place in the world you can get it for $10. So utilize that, guys. Go ahead,
Right.
Ronald.
With this new A2L refrigerant that's coming out, will we have to be recertified in the EPA or just continue education with it?
So there will be 2 separate options. So for people coming in, eventually, yes, it will be in the EPA course. So what they've done in the past, like the EPA course, obviously at one point didn't include, HFCs because they didn't exist at that point or they weren't on the market at that point. Now they do. So what they do is they update it, but they don't update it like every year. They update it like closer to every 10. So as they come out, as they become a problem and a thing that we have to work on, it will be part of the EPA. But those of you who already have your EPA, they're not going to require you to go back and do it again because that's a lifetime certification. So what they do, and I know this because they did this with my husband when he came up, and everything was R22 at that point. And then when HCFCs were outlawed, they did this for him. So what we will do is we will have training hours that we can complete. So you can have like a legitimized training that you take and say you need 8 hours of A2L training. You can take those 8 hours, send them into the EPA, and they will understand that you've been 100% certified in that. However, here's the gray area. The gray area is that most people won't even ask you. And I mean that with all of my love to the supply houses who are supposed to do their due diligence. But I've never even been asked for an EPA license. So that just kind of goes to show. And I'm a 5-foot tall girl covered in tattoos who they probably don't believe immediately is an HVAC tech. And they still don't ask me for my EPA. So, I mean, the chances of you being asked are very, very low. The exception to that is facilities. So the facility that you're working at, that's awesome, Frankie. It's good that they do. It really is. Maine is kind of a forgotten about territory. So it's definitely something that you want to have on you at all times. So basically what will happen is you'll take your training hours, you will submit them either to ESCO or to the EPA. In this case, SkillCat will probably offer them at some point. We do have some trainings coming up on this Tuesday series about A2Ls. Also, HVACX, every SkillCat student has access to HVACX as well. If you're not an HVACX student as well, go into Facebook and go find HVACX Coalition, join the group. We will have a bunch of different trainings on A2Ls in there as well. Those count towards training hours. So do skill cats. We're going to have Don Gillis from Chalmers, the biggest refrigerant manufacturer in the world. We're going to have him on to teach us about A2Ls in a couple of weeks. Definitely don't miss it. Go to Facebook and go to HVACX Coalition group and join. Every single skill cat student gets access to everything HVACX offers because we're one entity now. So make sure you utilize that. But yeah, that's the long answer to your question, Ronald. The short answer is eventually it'll be in the EPA. Until then, they're just going to have to monitor what we do on our own as far as education goes, or companies are going to have to offer it. And that's just how it goes.
Do you have that on anything other than Facebook, like on Instagram or anything?
I do. Yep. So you guys, HVACX is 100% run by me, except for our free tech support line is run by 5 techs. Everything else is run 100% by me. That's why SkillCat helped me and automated us so that we could do that a little bit easier. But yes, we are on Instagram under HVACX Jennifer. We are on LinkedIn under HVACX Jennifer. We are on every social media platform, TikTok, Facebook. The group itself, though, where you guys can talk back and forth to me and where you guys can converse with each other, you can post questions. All the announcements come out is on Facebook, though.
You said
and also HVACX.com.
Jennifer? Okay.
Yep, HVACX Jennifer.
Okay. All one word?
Yep.
Okay.
And then, yeah, the HVACX.com is our website where you guys can sign up for training and mentors. And you can sign up to be a mentor, too, if you wanted to. But again, every single SkillCat student gets access to all of that. So make sure you utilize it while you're here, for sure.